Tangents by Justin D'Souza. The learning objectives of this lesson are to describe relationships between radii and tangents and use those relationships to solve problems, and to describe relationships between the central and circumscribed angles and use those relationships to solve problems. We will look into both these objectives in this lesson, and the keywords are tangent to a circle, point of tangency, common tangent, circumscribed angle, circumscribed polygon. So these are the five keywords that we will see in this lesson. Now we will start with tangents. You can see this figure. This is a circle, and over here they have named a lot of parts. We had already seen diameter, chord, and radius. Now you can see there's something called tangent and secant. The difference between the secant and the tangent is secant is similar to a chord, but it's extended outside the circle. You can see here this much is a chord, but it's extended outside, and secant always has to touch 2 points, whereas the tangent only touches 1 point. It touches the circle such that only 1 point is touched, and that is called the point of tangency, and it will touch no other points of the circle. So here, if you draw a straight line from the center, that is the radius, to the point of tangency, it's always 90 degrees. This is a theorem. Always remember, when you draw a radius, that is from the center, if you draw a line, but instead of any part of the circle, if you touch the point of tangency, that means where the tangent touches the circle, it must be 90 degrees. And there is one more theorem that says if you have two tangents, say now this is one tangent and one more tangent somewhere over here, and if they both touch at the same common exterior point, say like this, then those both lines or segments are congruent to each other. Now here this is a tangent and this is also a tangent to the same circle, and they meet at an exterior point, and then this and this line till over here wherever it touches are equal. So these are the theorems. Now let's look into some problems here. Here we have to see how many common tangents can be drawn. Now, common tangent is a tangent which is a tangent to one or two, more than one circle. Now, here these both circle is having common tangent. If there was one more circle, then this would be the common tangent to all those circles. Here you can see there's one, two, three common tangents, and over here one, two, three, four. So here there are three common tangents, and over here there are four common tangents. It's very easy. Now, for a single circle, you can draw infinite tangents because you can draw at any point. But when there are two circles, that number reduces. It will be restricted. Here, 1, 2, and 3. Here, 1, 2, 3, 4. Now, let's look at this example 2. The line segment AB, you can see over here, is the radius of the circle A. That's the center A. This is the circle. Determine whether BC, can you see this BC, is a tangent to this circle. So we do not know whether this is a tangent, but this is the radius and this is to be found out whether it's a tangent or not. We need to justify answers. Now, what is the rule for this line to be a tangent? The radius must make 90 degrees at the point of tangency. So this must be 90 degrees. If this is 90 degrees, then this entire line AC must be the hypotenuse. But here 6, that is only from here to here, is known. This is 12 and this is 9. The radius is 9. We know this part is radius. Again 9 over here. So this total would be 15. 9 plus 6 is 15. So we know hypotenuse, that is AC squared, must be equal to the sum of the other two sides. That must be equal to AB squared plus BC squared. Now we will just substitute the values. AC is known to be 15 square. That must be equal to 9 square plus 12 square. Now here we can just square them up. 9 square is 81 plus 144. So here all you need to do is basically square this up. 15 square will be 225. And here we have 91 and 144. So let's add them up. 80, it'll be 220, 225. Yes, both the sides are same. You can check it in your calculators. But I will recommend you to use your calculators because you're allowed to use calculators for this. So this is your answer. That is 225 basically. Now, since it's a right angle triangle, both hypotenuse and the sum of the other two sides are equal. Over here you can see that means this must be a 90-degree. Only then Pythagoras theorem works. Since Pythagoras theorem is valid here, we can be 100% certain that this is the tangent because it's 90 degrees. So that's the tangent. That's what is explained here. And now the example 3 here, they have told QS is the tangent. They have already told this is the tangent to the circle R. Find the value of x. Now here we know this is x. This is x plus 2. That will be x plus 2 or 2 plus x anyway. Now here, if this is the radius and this is the tangent, then this is 90-degree. Hypotenuse is x plus 2 the whole square. That must be equal to the sum of the other two sides, x squared plus 4 square. You can directly put this in calculator and solve. I will just show you now. But once we are done with the calculator method, I'll solve it manually as well. Here, all you need to do is you use x as it is, like alpha x. Now it's, sorry, not square. Alpha x plus 2 the whole square. Close the bracket and square it up. Now this is the whole square. Equals, that is alpha and calc. Again, x square plus 4 square. Don't forget the square. And you cannot press equal to. If you press equal to, it will be a syntax error because there's equation. Now you need to press shift and solve this equation, and then this is not the answer. Press equal to. The answer of x is 3. So that's the answer. But now let's do it manually as well. Over here, you need to use a plus b the whole square formula. That is a plus b the whole square equals the first term square plus 2 times ab plus b square. So here it will be x square plus 2 times ab, that is 2x, plus b square, that is 2 square is 4, that will be equal to x square plus 4 square. So you can see x square and x square, both the sides, you can cancel this off because this x square to the other side becomes x square minus x square. That's the thing. And over here, I'll multiply this 2 inside, it'll be 4x. And this positive 4, I'll take it to the other side. And what about this 4 squared? 16 and minus this particular 4. So here it'll be 12 and we have 4x. X will be equal to 3, which we already got in the calculator and even over here. Because 4 divided by 12 divided by 4, dividing both the sides by 4, you will get x is 3. So that is how we can solve this problem. X value is 3 here in this case. So there's a similar problem just like we did just now. Please pause the video and try that one by yourselves. Now I will solve it up over here. From this figure, you can see the entire length 17 is given. This is x and this is 14. Very easy. And now if you see, this is 90 degrees, right? So because this is the tangent, whenever you have tangent, it is 90 degrees. So now you just see the hypotenuse. Hypotenuse will be 17 squared. This is the hypotenuse. So it will be 17 squared. First, I'll write the alphabetical, the segments, the line segments, the alphabet. AB square must be equal to the sum of the other two sides. You can write it as AC square plus BC square. Now we know this segment AB is 17 square, and now equated to what is AC? That is x square plus here we have 14 square, that is BC. That's the tangent line. Now if you recall 14 square, you can use your calculator, but it is 289. So I'll just write 289 here, simplifying. And over here x square as it is, and then 14 square is 196, I guess. Yeah, 196. So this is 196. Now I have all the values. Just take this to the other side. It will be 289 minus 196 equals x squared. And here 96, it will be 7. So it will be 900 minus 7 is 93 here, is equal to x squared. But here we have x squared, so you can just take the square root on both these sides. It will be root 93 equals x squared. Sorry, x value, sorry. Obviously, when you take root on both the sides, the square cancels off and you're getting 93. So it's over 9, it might be 9.5 or something because it's over square root 9. I mean, over the value of 9 but less than 10. So here it's 9.64. That's the accurate answer. So this is how we solve these problems. We have a real world problem here. A photographer wants to take a picture of a local fountain. She positions herself at point A so that the fountain will be centered in the picture. See, now this fountain is centered such that she's standing over here, and these two lines over here, see the AB and AC tangents to the fountain, see exactly tangents to the fountains. The radius for the circle to any of these point of tangency will be 90 degree. So if the lengths of the tangents are given in feet, see they have given over here in terms of variable x, we need to find the value of AB length exactly. So we know that when the two tangents meet at exterior points, these two segments are congruent. So over here it is 90 degree, over here also it's 90 degree. Now what we need to do is equate these both. So it'll be 7x minus 9 equals to 5x plus 5. Now we just solve for the x value. Since 5 is smaller, I'll take it to the other side. It will be 7x minus 5x is equal to, this minus to the other side will become 5 plus 9. Now it's 2x, sorry, I don't know why I wrote y. This is supposed to be x. It's 2x is equal to 9 plus 5 is 14. X is 7. But this is not the answer. Here, if you stop, you won't get full marks. We need the value of AB, not the x. So AB is given as 7x minus 9. Since we know x value, we can substitute 7 times 7 minus 9. It's 49 minus 9, that's 40. So it is basically 40 units. That is the value of AB. Now we need to solve the x and then we substitute back and then we will find the answer. Now if you do AC, what happens? You will get the same answer because those two segments are equal, isn't it? So it'll be 5 times 7 plus 5. And look over here, 7 times 5 is 35. And you are adding 5 to it, so it will become 40 itself. So that is the answer. In this case, the answer was 40. Yeah. X is 7, yes, but we need to find AB as well. Now, another same problem, please do try it by yourselves. I'll directly do it because over here these two values are equal. So it will be 3x minus 3.5. That will be equal to x plus half or 0.5. All the x variables to one side. So 3x minus x when it moves the equal to. And this over here to the right, it will be 3.5 plus and, sorry, not x. 3.5 plus 0.5. Now we can solve it up. It will be 2x is equal to 4x is equal to 2. So that will be the answer for x. But that is not the solution which we want. We need to find DE. So 3 into x is 2 minus 3.5. We know it is 6 minus 3.5 or 2.5. I'll write it as 5 by 2. Even if you substitute over here, that's going to be the same thing. X is 2. 2 plus 0.5 is 2.5 or 5 by 2. So the value of DE is 2.5 or 5 divided by 2 feet because it's mentioned as feet. Now we will look into circumscribed angles. Circumscribed angles are the angles that are formed when there are two tangents touching the circle. Or any tangent. If this angle formed is with the tangent, then that's circumscribed angle. So the circumscribed angle basically is the angle that is with the tangent over here, tangent to the circle. This will be 90 degrees over here. But there is a rule. So now if this is 90 and this is 90, this over here is basically a quadrilateral, 4 sides. So total angle will be 360. So this and this when you add up should be 180 because this is 90. So 360 minus 180 is 180. So add the mid P and S, you must get 180. So we'll solve problems on this. Now circumscribed angle polygons, for example, where all the sides are touching the vertices, the circle is always touching. Now, circumscribed angles, on the other hand, is basically something like this, where the circles are touching, are inside, but all the points are exactly touching the triangle or any polygon. But remember here, this is tangent. So all these lines are there, right? They are all tangent to the circle. These are not circumscribed. If they're not touching or if they're not properly enclosed or circumscribed, then they are not circumscribed polygons. We will look into a problem. Here the angle EGF, that is this angle G, is given over here to be 19x plus 9, and this angle D is given to be 10x minus 3. We need to solve for the measure of angle D. We know these both are supplementary in the sense when we add them up, 9x plus 9 and add it with 10x minus 3, they must be equal to 180 because they're supplementary. So solve it up. It'll be 29x plus 6 is equal to 180. You can take this 6 to the other side. It'll be 29x equals 180 minus 6. That will be 174. Now 29 three times. Yeah, so you can just sorry, 6 times. Okay, 29 three times is 90, and two times, yeah, it'll be exactly 174 by 29. You can solve this up. It'll be x is equal to 6. So this must be the answer, but this is, sorry, this is part of the answer, but this is not the final answer because we need to find the measure of angle D, which is 10x minus 3. Now substitute the x value, 6, and solve. It will be 60 minus 3, that is 57 degrees. So this will be your final answer. That is the angle of D. So you can see the x value was 6, and then substitute over here and solve. That's the answer. Please do try to solve this problem by yourselves, and then we will solve it together. Let's see what is given over here. X, W, Z. So this value is 7x plus 10. And over here, Y value is given as 4x plus 5. So this is over here, 4x plus 5. Now we know that when we add these both angles, they are supplementary. So it will be 7x plus 10 plus 4x plus 5. That will be equal to 180. So solve it up. 7 plus 4 is 11x plus 15. That is equal to 180. Take this 15 to the other side. It will be 165. Now divide x is equal to 165 by 11. So this over here, 11 times 15 is 165. So the answer must be 15. That is the x value. But it's not the final answer. Now substitute back in this equation 4x plus 5. We know 4 times 11 will be 44. And add 5 to it. The answer is 49 degrees. So this will be the final answer. So the answer over here is 49 degrees. Now we will move on to the next type of problem, the last one over here. See, you can see the circle is circumscribed in this triangle. And whenever it's circumscribed, you can see these points are the point of tangencies. You can see this is all the tangency points. So what happens is these are tangent lines. And now if this and this is tangent line to the same circle, we know they both will be equal, isn't it? So from here we can see if this is 14, then this will be 14. This is 11, this is 11, 7 and 7. So if you want to find the perimeter of the triangle JKL, just add them all up. 14 plus 14. You can just times 2, do times 2. So 11 plus 11, instead of that I'll write 11 times 2 is 22 plus 14. So we have over here 14 times 3. So we know it is 42 plus 22. The answer would be 64. This is the perimeter. That's it. So it's very easy to solve this. All you need to do is add them all up and the answer is 64. Now this is in terms of, there's no unit mentioned exactly. So you can just write units. That's it. So it's 64 units. Now, what about this one? Please do pause it and try to solve it by yourselves. Now we will try it over here. See, 3 and this is 3, this is also 3, this is x and this is x. So we know whenever it's circumscribed, these will both will be the tangents, and then these are equal to each other. These both are equal. Over here, they have given the perimeter to be 18. So that means when you add them all up, it will be 18. So here you can see this is x, 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 x. Add them all up. It will basically be x plus x plus x plus x, or I'll write it 4x together because 4x's are there. And this is 3 plus 3 plus 3 plus 3. It would be 4 times 3, that is 12. Now you can solve it over here. Take this to the other side. It will be 18 minus 12 equals 4x. And it will be 6 is equal to 4x. Or take it to the other side. 6 by 4 equals x. Now this is 3 by 2 equals x. Or 1.5 equals x. So this is the answer. Now you can solve it and calculate it directly and get the answer, but if you want to solve in steps, that would be the answer. So this is how we basically solve this problem. The answer is A over here, that is 1.5 units. Always write in terms of units. And we have finished this particular lesson. I hope you have found it helpful. Please do subscribe to my channel and please do share my videos to anyone who might find it helpful. All the lessons for grade 9, 10, 11, 12 are available. I hope you all have a great day. See you in the next video. Happy learning.